All right, so guys, this is chapter 3. I'll just set up the PowerPoint, or unit 3. Now, I think you guys will like unit 3 now that we've done unit 1. Okay, let me just double make sure I'm sharing that. Okay. Unit 3, halfway through the course, unit 3 is basically everything we did in unit 2, except now we're going to talk about alkenes and alkynes, but really it's the same thing over again. We're going to learn how to name them. We're going to learn a couple of reactions with them, and then that's it. We move on. And then the next unit, which we won't get to for a while, obviously, but that would be unit 4. That would be on aromatics. So unit 3, we're going to look at the structure, the naming, and the reactions. Now, between us, wink, 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 this is good, this is really, really good, and this is really, really good. I'm not saying we're going to skip section 3.3, but we're not going to go into too much detail there. So I won't put an X through it, but it's not really the important section in this chapter. Today, I think we'll get through the structure. Then tomorrow or next day, we'll start naming them. And of course, like I mentioned, probably a week from today on Thursday, we'll have a little review for the test. So let's start with section 3.1. I'll do some of this today. There is, yeah, and then I am says in the chat, 3.3 sounds difficult. It is. It can be quite difficult, but luckily in this course, it's not too bad. So we're going to look at the structure of alkenes and alkynes. And I've been saying these words now for a while. Alkenes are, double bonds. Alkynes are triple bonds. That's all you need to know. I shouldn't say that's all you need to know, but I mean, that will get you far. Okay. I think theoretically, like a quadruple bond is possible, but you never ever see it. There's always at least some hydrogens involved. Okay. So in organic chemistry, a diene, we'll talk about naming all these, not today, maybe on Monday's class or whenever our next class is. But a diene is when you have two alkene units in the same molecule. So we'll talk about naming later. That'll be next class. Okay, so this though, wink, wink, this would be a good multiple choice question. What are the 3 classes of dienes? And it all depends on the location of the double bonds. And I'll show you all 3 of these. I have pictures of all 3. So there's, yawning here. There's cumulated dienes, conjugated dienes, and unconjugated. So let's look at all 3 of these. All right, the first one, a cumulated. Cumulated in English means kind of like to put everything together. Like your cumulated grade is all of your grades put together, your labs, your tests, your final exam. So to cumulate in English means to combine or gather together. In chemistry, it means that the double bonds are gathered together and they share a common atom. So 2 double bonds attached to the same carbon, this would be called a cumulated diene. So these are together on the same carbon. Sorry, just checking the chat. Accumulate and cumulate kind of mean the same thing. The definition of cumulate is gather together and combine. And let's see what accumulated is. I think it's like gradually gather or acquire, gather, build up. Yeah, they basically mean the same thing. English is really weird. We would say, like in the winter in Canada, the snow accumulated, meaning that like overnight the snow built up and up and up. Anyways, so accumulated means together. Now, Conjugated. You guys might have heard the word conjugate in math. Let's see what it means in English. I'm actually only getting the chemistry definitions. Let's see. I'm getting biology, chemistry. In grammar, it means give different forms of a verb. So that's not really going to help us. Conjugated means they're adjacent, I guess you could think of. They're next to each other, but they're not sharing a carbon. So the simple definition is a conjugated diene have conjugated double bonds separated by a single bond. And there's a reason I'm teaching you these terms. Conjugated dienes are more stable than other types of dienes. This is because of resonance, and this is something we'll talk about in the next unit. Aromatics also have resonance. And resonance is the idea that the bond can be moved. It's shared over a group of bonds. And this resonance is what it's called. This shifting of the double bond location makes the molecule itself really stable. And we'll talk about this more in unit 4 when we do aromatics. Aromatics have like the ultimate resonance. Okay, I'll do a little review of this now in a second. Unconjugated, they don't follow any of these principles. They're not touching the same carbon. They're not split apart by one carbon. They're just double bonds separated by 2 or more single bonds. They're less stable than other types of dienes. So there's 3 types. That's pretty fast getting through there. Let me just kind of explain them for you. Okay, so.
Hello, sir.
Hello.
Sorry, I'm late.
No problem. So if I had accumulated alkene, you know, imagine I had an alkene that looked like this. I guess I could take this alkene. Accumulated would mean the 2 double bonds are next to each other. Okay, so that would be, the lines aren't drawn very straight, but they share the same carbon atom. Oops. Okay, they're sharing this one. All right, let's do another one. The conjugated alkenes. All right, so let me fix that J there. Conjugated, there we go. We could do, I guess, the same molecule. Okay, but conjugated would mean they are split apart by 1 single bond. So this would be conjugated. They're split apart by a single bond. Okay, and then the last one we had were unconjugated. Oh, I erased my slide. Oh, I can draw that again really quick. We're unconjugated. So sorry, I'll draw this again really quick. And unconjugated. So the summary, I'll draw the same molecule. Accumulated would look like this. Conjugated would have a gap in the middle, like this. And unconjugated has no real pattern. Okay, so unconjugated would look like that. There we go. So accumulated, the double bonds are attached to the same carbon. Conjugated, the double bonds have a single bond between them. One thing I'll mention, just so that you know the importance of this, these are the most stable. And we'll talk more about stability in unit 4, because this has resonance just like an aromatic ring. And then unconjugated at the end. So these are 3 that you should know could be a good multiple choice. So I could show you a molecule and say, is this type of alkene Cumulated, conjugated, unconjugated, or, none of the above. All right. Well, I don't think I want to waste too much time. Um, Let me just introduce naming, and then that'll be it for today. It's Thursday. I don't want to go too far. We're doing really good for time, but it's only 10 to 1. So just give me a couple more minutes. I'll introduce this section, and we can practice this more next week. So section 3.2, this is our longest section. This is obviously the naming. And guys, honestly, the good part about this is you already know how to name most of these. The only trick, I guess, is that you need to add one thing. You need to tell me that it's an alkene and tell me where the double bond is. That's it. So it's a lot easier than it sounds. Yeah, and Niam says in the chat exactly, "een" instead of "ain." And again, the only thing extra is you have to tell me where the double bond is. Okay, so it's easy. We'll do a couple of examples maybe, and that's it. So we give alkenes. We'll start with alkenes, IUPAC names by replacing the family name, actually the suffix, to "ene." And for an alkyne, we would change the ending to "yne." Now, there are two simple alkenes, and because they're so simple, and they are well known with common names. So, we would just call this for IUPAC, instead of ethane, we would call it ethene. And for propane, we would call it propene. We don't need to write where the double bond is because it can only be attached to the first carbon. So we, as IUPAC people, we would call this ethene and propene, but you might in the engineering world hear the word ethylene or propylene. These are just older names, kind of like that whole tertiary and iso and sec-butyl. Chemistry had different names maybe 40, 50 years ago. And you might hear these. Some of these are used to make polymers. But anyways, we're not worried about polymers in this course. Not really. So let's just get into the normal names here. So I'll show you 2, 3. Okay, I'll show you a couple of these, and then maybe we'll stop for today. Okay, this is probably one of the easier ones you could get. Now, I don't have any, I guess I don't have a list of rules here, but the rule is basically in this paragraph. When you're numbering these carbons with double bonds, or I should say these molecules with double bonds, the double bonds take precedence, which means, they take charge. They are counted first over anything else. So when you're numbering a carbon chain, or an alkene or alkyne, the double or triple bond gets numbered first or lowest. Okay, that's really important. So the double or triple bond gets numbered the lowest. So when I'm numbering this molecule, instead of starting here and going 1, 2, 3, 4, if this was just an alkane, that's how we would number it, because we would say, oh, well, we'll have the methyl on the lowest number. But because this has a double bond, we're going to start. So the double bond is the lowest. Okay, so on the first carbon, we have our double bond. And on the third carbon, we have our methyl group. So we would call this 3-methyl-1-butene. Instead of butane, we would call it butene. I'll do more practice on this, don't worry. I think this is just an example, but I do have more practice. All right, so let's look at this one. Now, this one's pretty crazy looking. I almost regret having the green here, but think of the few ways I could number this molecule. I could go Now I must have the double bond in my chain somewhere. So like if I went this way, 1, 2, 3, 4, 5, 6, 7, I'm not including my double bond. So that would be very difficult to name. So let's try this. 1, 2, 3, 4, 5, 6. This will give me my bromine and my double bond in the chain. So this is pretty good. I already know the name of this group. It has 3 carbons. So this is a propyl group. Okay, so I would call this hexene. So again, working backwards. So 6 carbons, hexane, but it's a double bond, so I call it hexene. On the second carbon, there's your double bond, so it's called 2-hexene. On the third carbon, you have a propyl group, and on the 6th carbon, you have a bromo group. So actually, what I could probably do here is color this up for you. So again, breaking this name down, on the second carbon, oh man, this pen. That's why I put the 2 here. On the third carbon, let's try green. On the third carbon, I have my 3 propyl group, and on the 6th carbon, I have 6 bromo. So that's kind of the breakdown of this molecule. Pretty, I don't know, pretty easy-ish. If this was just an alkane, it'd be named completely differently, which is kind of interesting, but excuse me, not that hard. Cyclo. Okay, here's what I want to do, guys. I want to show you cyclo. I think I'm going to skip common names for now and just do 1 or 2 practice with you, and that'll be it for the week. So I'll just show you cyclo. I'll come back to common names on next class on Monday, and I'll just do these 2 examples with you, and that'll be it for today. So maybe another 5 minutes or so. Okay, so I am going to skip 2 slides, but I will come back to this. Yeah, I didn't sleep too well, and plus I haven't had a coffee yet today. So that's probably it. Probably why I'm so tired. All right. So cycloalkenes are named in the exact same, excuse me, same way as an alkane, I should say. The only difference here is we change the ending to ENE. The other thing to consider, you'll notice that all of these cyclo groups, they don't have any numbers in front of them because it's assumed with a ring that you start at number 1. So obviously here I would number this like 1, 2, 3, 1, 2, 3, 1, 2, 3. You're going to start the ring where the double bond is on the first carbon. The other thing I'll mention, and I'm going to show you this in the example I'm going to do, make sure you're counting over the double bond. So don't start here, right? You need to go over or include the entire double bond. So I have to start here. And I'm going to show you this in an example. Okay, just maybe 3 more minutes and we're done for today. I got another 2 classes, but I'll live. I'll probably make a tea or something after this. So I will do the common names on in the next class, especially vinyl. This is an important one to know for polymers, polyvinyl chloride, PVC. We'll talk a little bit more about vinyl later, but I just want to, give you an example of how we would name these. And honestly, some of you guys could probably name these right now, but let's kind of do these together. And then next day, maybe I'll get you guys to name these 2 or something. Maybe even sketch these 2, we'll see. So let's just do these 2 nice and simple. Okay, so I'll start with the one on the left, of course. I could number it this way, 1, 2, 3, 4, 5, but I got a feeling, or I have a feeling that I could get my numbers lower going the other way. Remember, I want the double bond to be the lowest possible number. So 1, 2, 3, 4, 5. There we go. That looks a lot better. Okay, so on the second carbon, I have my alkene. On the fourth carbon, I have my methyl or methyl. All right, I mean, that's it. So I would call this, I guess I could work backwards. This is pentane, but because it has a double bond, I would call it pentene. Now, you guys need to tell me where the double bond begins, and it begins here. So you would call it 2-pentene. Okay, so you're almost there. You got about half marks. The only other thing you guys need to do is tell me where that methyl group is, and you would call it 4-methyl. There we go, 4-methyl 2-pentene. The only difference this would have than, say, an alkane is, well, we would number this a little differently. But that's it. I mean, the name remains almost the same. We just make sure we add the number where the double bond is. Okay, the next one. This one's a good one over here. This will be my last one for today. I need to number this, and I want to number it so that I include the double bond, but I also hit this ethyl group at its lowest possible number. And there's really only 2 ways to do this. And I have a feeling we're going to get the same answer. So 1, 2, 3, 4, 5. That's one way to number this. Guys, remember, very important to note, when I'm numbering, I have to go over the double bond. I can't go like 1, 2 that way. You need to go over the double bond. The other way to number this would be, and I will erase these numbers. The other way would be to start here and do the same thing. Again, go over the double bond, 3, 4, 5. So it really doesn't matter which way I number this. It's going to be cyclopentene. Oops. See that? I just almost wrote cyclopentane. I don't need a number here because since it's a ring, we're always going to start counting on the double bond. You could put a 1 here, but you don't need to. And the only other thing I would add to this is, of course, I want to write down that on the 4th carbon, I have an ethyl. This technically would be one word. Like, well, that's as close as I can get, because there's no numbers separating it. You, again, if you did this on a test and you put a 1 above this for the cyclopentene, I don't care, but you don't need it. All right, so that's it. I mean, that's writing UPAC names, or systematic names at least, for alkenes. Guys, if these were alkynes, it would be the exact same thing. We would just change the ending to YNE. So that's basically it for me today. It's only 1:03, but what you guys should do maybe this weekend or something, if you're bored, why don't you try these? See if you can get the names for me, and then next class, we'll go through the answers. Also, if you're bored next week or this weekend, you can try these. And we'll go through the answers on the next class as well. Okay, now I know you guys are pretty busy, but good luck on I know some of you might have engineering midterms this week or next week, so good luck with those. Have a great weekend. I'm gonna hit stop record now, and yeah, have a good weekend.
Thank you, sir.
Thank
You
you.
too.
You too.